All right, welcome to Physics Video 1.4b. Video 1.4a ran longer than I hoped. So in 1.4a, we covered these guys. So now we got to do this. All right. So basically what we're going to do is we're going to learn how to draw the graphs given a story problem. So here we go. So you're going to be given a big example like this. Kind of like in 1.3, there's going to be different chunks to the motion. So here we go. Gordon the cat is on a giant slide. He begins at the bottom of the slide, which is a position of 0. And then he runs up the slide at 3 meters a second for 4 seconds. He stops for 2 seconds. Then he crawls up another 6 meters at 3 meters per second. And then finally he slides all the way back down to the bottom at 9 meters a second. Make a position time graph. Okay, so pause the video, write this down. Okay, and then what you're going to do is you're going to break it up into chunks, just like we did in video 1.3b. All right, so the first thing is this. He runs up the slide at 3 meters a second for 4 seconds. So that's chunk number 1. Okay. The next chunk is this. He stops for 2 seconds. So that's our chunk number 2. Right? Then he crawls up another 6 meters at 3 meters a second. That's going to become our chunk number 3. And then finally slides back to the bottom at 9 meters a second. That's going to be our chunk number 4. Okay? So what you're going to do is start by writing down what you know for each of the chunks. So I just shrunk this down so that we've got a little bit more room to work. And like I said, we're going to start by writing down what we know for each of the chunks. So in chunk number 1, here's what we know. He runs up the slide at 3 meters a second. So that's a velocity because it's how fast he's going. It's meters per second. He's going up the slide, so it's positive. I'm going to put a little plus sign in front of it just so that I know that I actually checked the sign. All right, and then it tells you that he does that for a time of 4 seconds. All right, but our goal is to make a position time graph, and I don't know anything about my position. I know my velocity, I know my time, I don't know my displacement. So I'm going to take a second and I'm going to find it. All right, so displacement is velocity times time. We're going up 3 meters every second for 4 seconds. My displacement for this chunk is going to be 12 meters. Okay, excuse my sniffling. Chunk number 2. He's going to stop for 2 seconds. So if he's stopped, that means his velocity is going to be 0 for those 2 seconds. And so during those 2 seconds, he's not going to go anywhere, right? So the displacement's going to be 0. So that's chunk number 2. Chunk number 3 says he goes up another 6 meters. So that's how far he went. It's going to be 6 meters. The velocity is once again 3 meters a second. I don't know why I wrote a problem like that. That's weird that I would do that. So velocity is 3 meters a second. This time I don't know the time. So let's find the time. So the time is going to be displacement over velocity, 6 meters, 3 meters a second. My time for that chunk is going to be 2 seconds. All right. And then finally, chunk number 4, it says he slides back to the bottom at 9 meters a second. So the velocity is 9 meters a second. Since he's sliding back down, it's going to be negative, right? But notice here, I don't know my displacement or my time. Okay? So that's kind of as much as we can do right now. All right? Now, eventually what we're going to want to do is we're going to want to take all of this information and put it into a graph. My strong recommendation for you, though, is before you make your graph, make a chart. All right? And what the chart is going to do is the chart is going to keep track of, at different times, what's his position. Now notice, this is position. Whereas this, triangle X, is not. It's displacement. That's change in position. Okay? So here's what we're going to do. We know that at time 0, he was at a position of 0, right? So that's that. Then, during chunk number 1, maybe it would help to do this. Let me see. So let's do this. Let's draw the slide. So here's the slide. So the cat starts at the bottom. right? And he's going to climb up the slide. So in the first chunk, he's going to go up 12 meters, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's chunk number 1, was him going up 12 meters, right? So if we started the stopwatch down here at the bottom, my time is 0. 4 seconds are going to elapse by the time he gets to here, right? So over here, 4 seconds, his position now is going to be 12 meters, right? Because he started at 0 and then went up 12. Okay? So that, I think, is pretty straightforward. This is where people start to make mistakes, all right? In chunk number 2, he stops, right? So he's going to just hang out here for a little bit, right? So 2 more seconds are going to elapse. 4 seconds have already gone by. We're going to add 2 more seconds. That gets us up to 6 seconds. And at the end of those 6 seconds, the cat is still going to be at the same spot on the slide. So his position is still going to be 12. Okay? So basically what's going to end up happening here is as you go through your chart, you're going to keep adding up your time, right? We started at 0, and then we added 4, and then we added 2, right? 0 plus 4 plus 2. And then similarly for your position, you keep adding your displacements. We started at 0, and then we added 12, and then we added 0. 0 plus 12 plus 0, right? So for chunk number 3, he's going to go up another 6 meters. So we're at 12 now, right? So now we got to go up 6 more, right? So 1, 2, 3, 4, 5, 6 is going to get us up to 18 meters, right? So that takes 2 more seconds. So now we're up to a total of 8, 6 plus 2. And our position went up by 6, so 12 plus 6 is 18 meters, right? So now, here's my cat up here at the 18 meter mark. Cool. So now we can finish our chunk number 4. Because what we know is in chunk number 4, he's got to go back all the way back down to the bottom, right? So for chunk number 4, the cat's going to slide all the way back down to the bottom. So I know that his final position is going to be 0, right? Because he's going back to the bottom. But what I don't know is how long it took. But I can figure it out really easily. Because look, if we're going from a position of 18 down to 0, then up here my displacement is going to be negative 18 meters, right? Because you've got to get from that position of 18 back down to 0. So now I can find my time by doing displacement over velocity, negative 18 meters. Negative 9 meters a second. Sorry, my writing's getting a little squished here. It's going to take us 2 seconds. All right, so 8 plus 2 gets us 10 seconds. There we go. All right, so this right here, coming up with this chart, is probably the hardest part. Once you get the chart, the rest of this is going to be easy. Okay, so let's do this. Okay, so what we're going to do here is this. We've got our data table that we just made on the previous screen, right? So now we just got to plot the points, all right? So your horizontal axis, remember, is time, and your vertical axis is position. So we started at time 0 at a position of 0, right? That's this first point here, all right? Then after 4 seconds, our position was 12. So go over to 4, up to a position of 12, and put a dot. All right. After 6 seconds, our position was still 12. After 8 seconds, our position was 18. So 18 is going to be halfway between 16 and 20. And then by the end of 10 seconds, we were back down to 0. And then you just connect the dots. Ideally, use a ruler. And there's a graph. Cool? There you go. Have a good day.